Okay, so in this video I'm going to go through question 5 of the 2014 exam paper. So question 5 has 3 parts. So part A asks you to describe in detail the graphical integration method for a gradually varied flow in open channel flow. So that requires you to write a couple of sentences, and for that I would expect you to sort of explain the direct step method and then the standard step method. So that would give you 8 marks for that question. So it'd be a description of the standard step method and how that works, and a description of the direct step method and how that works. Details on both those methods can be found in the lecture handouts. So there's no reason for you to not be able to answer that question, part of the question. Part B and C is where you need to do the analytical work. So part B is giving you the parameters. It's saying you've got bed slope of 1 in 25, Manning's n of 0.015, carries a discharge of 2.5 meters cubed per square per meter, and it says there's a sluice gate which controls the flow, and the question is asking you what is the normal depth for the flow situation. So part B is only asking you to work out the normal depth. Yep. So let's do that first. So part B, the parameters that are given, so S slope is 0.04, N is 0.015, and small q is 2.5 meters cubed per square per meter. Yep. So you need to work out yn. Yn is given by, again, q equals 1 over n times r to the 2 over 3 times s to the half times a. So again, you can manipulate this equation fairly quickly because in the question it says it's a wide channel. So again, always make sure you read the question, because if it doesn't tell you it's a wide channel, then you can't solve this question, because R is A over P. So you're going to have area, which is B times Y, and wetted perimeter, which is B plus 2Y. So you've got Y at the top and Y at the bottom, so you can't rearrange the equation for Y. However, when we say it's a wide channel, that simplifies it because it means that R is equals to Y. Yep. So similar to in the last video, I'm going to manipulate this equation again. So Q equals 1 over n, y to the 2 over 3, s to the half times a, and then again area, which is just b times y. So now we know that q equals to qb, so you can do this. qb is equals to 1 over n, y to the 2 over 3 s to the half, b times y. Yep. Now b cancels, so you just get left with q equals 1 over n, y to the 2 over 3, s to the half, y. Collect y, q equals 1 over n, so you're collecting that with this one, 2 over 3 plus 1, so you get y to the 5 over 3, s to the half. Yep. And then again you just rearrange this for yn, so yn is equals to q n over square root s, and that's all cubed, so similar to the last video. So yn is equals to 2.5 times 0.015 over the slope, which is 0.04. That's all cubed. and the answer you get from that is 0.366 meters. So part B, that would give you 4 marks for initially writing down the Manning's equation, manipulating it to work out an equation for yn, and then subbing in the values for yn and working out what yn actually is. So that would give you 4 marks. So 8 marks you should be able to automatically guarantee yourself, because part A is really easy. It's just remembering what the two methods are. Part B, again, is fairly straightforward, just working out yn. Part C is the tricky part, is the most difficult, sorry, and that's why you get 8 marks for that question. Now, this is where you can make mistakes, and what it requires you to do is so the depth just downstream of the sluice is 0.5, and this is what is the minimum distance between the sluice gate and the overflow, which would ensure that the profile after the sluice gate returns to normal depth. So it requires you to do an integration, probably 1-step integration. The question doesn't tell you, but you only need to do 1 step. Yeah. And the question again doesn't tell you which method to use, so you can either use a direct step method or you can either use a standard step method, so it's totally up to you. Yeah. So I'm just going to use the direct step method here. So part C, so I'm going to say delta x equals to delta y, and that's 1 minus f of r squared s naught minus s of f. So that's the direct step method. Direct step method. So again, it requires you to create the table. So just going to draw a line. So x, so at 0. Yep. Y is 0.5 as given in the question. Yep. F of r squared. You'll notice that I'm not, for this table, I'm not writing or working out area or wetted perimeter. And the reason for that is in the question it doesn't give you what B is. Yeah? So you don't have B for this question. So I can't work out the area or the wetted perimeter. But what I can work out is the Freud number. And I'll work that out by manipulating the Freud equation. Yeah? So f of r squared is equals to b squared over gy. So you get, you know that v equals q over a. So if you sub that back into the equation, you get q squared g y a squared. Yep. Right, if I open this up, so you get q squared g y b times y squared. So that's just the area. Now you know big Q is just small qb. Yep. So you get g y b times y squared. So the b cancels and you collect the y. So b squared goes with b squared, and then you get y squared plus y to the power 1. So finally you get q squared over gy cubed. Yep. So you work that out as 2.5 squared divided by 9.81 times 0.5 cubed. Yep. And the answer for that you get is 5.0968. Yep. The next part is 1 minus f of r squared. So it's just 1 minus the f of r squared, which you just worked out. So you get minus 4.096. Yep. The slope s of f. Again, you work out S of f by using the Manning's equation. Yep. So you'll use this equation here to work out the slope. So if you rearrange that equation, so S of f is equals to q squared n squared y to the 25/9. Yep. And you get 2.5 squared times 0.015 squared over 0.5 to the 25/9. Yep. And the answer you get from that is 0.12964. Then you do S0 minus S of f. So S0 is given, it's 0.04 minus S of f, which you've worked out, and the answer you get for that is 0.0303, and then you work out delta x. Yep. Now, what do you use for delta y? So you can work out delta x is equal to delta y. But what is delta y? Yeah. So it says the depth just upstream of the sluice gate is 0.5 meters, and it says what is the distance before the profile returns to normal depth. Yep. So the profile needs to return to normal depth. So do we know the normal depth? Yep. Yes, because we've calculated it in B. So the normal depth is 0.366. So delta y is equal to 0.5 minus 0.366, which gives you 0.1337. Yeah. So that's delta y. So now you can calculate the delta x. So delta y is 0.1337 times that by negative 4.096 over 0.0303. Yep. And the answer you get for that is 18.1 meters. Yep. So that would give you the full 8 marks for that question, working out delta x. Yep. Now, when I was looking at the mark scheme for the 2014 paper, I noticed an error with this question. I think on the solution it says 83. So that's incorrect. I think there's an error, or it's a typo. But the correct answer is 18.1 meters. Again, you can do this question again, but you can use the direct step method by taking the mean. If you do the mean, you'll get a different answer. But again, that would give you full marks. creating the table, working out f of r squared, working out s of f, and then finally making sure you worked out the correct delta y, and then finally working out delta x. So that would give you full marks for that question. So that is the so going back to looking at 2014 paper, question 1 you need to write is not analytical. You just need to write a paragraph on FRM again. Question 2 is analytical. There's a video for that. Question 3 is not analytical, requires you to explain the 7i equation. Question 4 is analytical. There's a video on that. Question 5 is analytical, and there's a video on that. So hopefully this video has been helpful, and you should be confident in answering the examination questions.